So in a previous video we spoke about one-sided continuity and what it means for a function to be left or right continuous at a particular point. But in this video we're going to show that if a function is continuous at a point, then it has to be both left and right continuous at that point. So we know a function f of x is continuous if the limit as x approach is continuous, I should say is continuous at x equals a, if the limit as x approaches a of f of x equals the function value there, equals f of a. And so this, what does this imply? This implies that, so we can say, I guess this implies several things. One, the limits from the left and right are equal. So limit as x approaches a from the left of f of x equals the limit as x approaches a from the right of f of x. And we'll just call these two equal limits the limit as x approaches a of f of x. So the left and right limits are the same, and we'll just call them the limit. We'll just encapsulate them into the limit as x approaches a of f of x. We also know that f of x is defined at a. At x equals a. And we also know that the limit as x approaches a of f of x is equal to what that function is defined as at x equals a. So is equal to f of a. Okay, so what can we glean from this? We see that the limit as x approaches a of f of x is that, well, that's equivalent to both the limits as x approaches a from the left and the right of f of x. So putting statement 1 and statement 3 together, we can draw statements for, we can conclude that, well, we can draw the conclusions that are going to be in statements 4 and 5, and statement 4 will be the limit as x approaches a from the left of f of x is equal to f of a. And this just comes out of the fact that, well, the limit as x approaches a from the left of f of x, well, that's just equal to the limit as x approaches a of f of x, which is in turn equal to f of a. So if these two things are equal, and these two things are equal, then this and this must be equal as well. And we can say something very similar for the limit coming from the right. The limit as x approaches a from the right of f of x equals f of a. And we're basically doing the same thing here. Well, the limit as x approaches a from the right of f of x is equal to the function value. But the limit as x approaches a from the right is also equal to the limit as x approaches a of f of x. And that limit, or my mistake, we're concluding this. We're concluding 5 from statements 3 and 1. So the limit, knowing that the limit as x approaches a of f of x is equal to f of a, and knowing that that limit is equal to the limit from the right, we can say the limit from the right is equal to the function value. And that's the statement we're making here. And this statement, look at statement 4 here. The limit as x approaches a from the left of f of x equals f of a. Well, this is the definition of left continuity. This is the same thing as saying that f of x is continuous from the left at x equals a. And this here is the same thing as saying f of x is continuous from the right at x equals a. Essentially, we've shown that if f of x is continuous at x equals a, and that statement is equivalent to this equality here, then we know that f of x is both left and right continuous at x equals a.